In this next part of the geometric sequence lesson, we're talking about the recursive formulas for a geometric sequence. And this would be for any type of sequence. So sometimes the sequence is defined by giving the value of t sub n, an nth term, in terms of its preceding term, which would be the n minus 1 term. A recursive definition consists of two parts. Number one, an initial condition that tells where the sequence starts. So quite simply, it might start out with like a sub 1 is equal to 5. A recursion equation that tells how any term in the sequence is related to the preceding term. So it's going to relate the nth term to the n minus 1 term. So it's important to recognize these in the formula. And then it might have something like this, where it just has a 2 in front, like we're multiplying by 2, and then maybe we're adding 1 to that. So if that's the case, your first term is 5. What are we going to do to the previous term? We're going to multiply by 2. We're going to add 1. Then we're going to multiply that term by 2 and add 1. And multiply that 2 and add 1, and so on. So more examples of recursive formulas. So for this first one, I'm going to write down a sub 1, I'm going to write down a sub n, and a sub n minus 1. And then put in my information. I know my first term's 3. What are they doing to the previous term? They're multiplying by 4. So I could just put a 4 out in front like that, showing a recursive formula. This next one, I'm going to write down my first term in my recursive equation. The first term is 2. What are we doing to each term? Previously, we're multiplying by 5. This last one's one of those special ones. It's not arithmetic, it's not geometric. It's kind of a combination of the both. We're starting with 3, and then what are we doing? We're doubling the 3, and we're adding 1. We're doubling the 7 and adding 1. So we're taking 2 times the previous term, and we're adding 1. Those are examples of recursive formulas. Remember having 2 parts. All right, remember to find the sum of the arithmetic series. You didn't have a whole lot of practice with this, but the formula was to find the sum of n terms. It's n over 2, half of n, times the first term plus last term. So if I gave you this arithmetic series, and asked you to find the sum of the first 6 terms, it'd be 6 over 2, first term plus last term. So it'd be 3 times 19, which is 57. Now, to find the sum of a geometric series, a little bit different. You need to know, and there's different ways to write this. Might be easier to know it's first term times 1 minus r to the nth power all over 1 minus r. First term times 1 minus r to the nth power all over 1 minus r. So if I had this geometric series, so you can see the ratio is 4. Let's say it just keeps going. If I was going to ask you to find the sum of the first 10 terms here, it'd be 2 times the first term, 1 minus 4 to the 10th power, all over 1 minus 4. And we'll do some examples using that formula in the next slide. So again, just to remember, find the sum of a geometric series, it's first term times 1 minus r to the nth power all over 1 minus r. So in the first example, your first term is 2, the ratio is 3, we're finding the sum of the 8 terms. So that's all you need to know. So S of 8 is going to equal 2 times 1 minus r to the 8th power over 1 minus 3. Now, I like to do a lot of this mentally. 1 minus 3 is negative 2. And then you could cancel the 2 and the negative 2 to just be negative 1. So basically my answer here is going to be 1 minus 3 to the 8th power. And then I'm going to divide that by negative 1. And my sum of those first 8 terms would be 6,560. In the next one, my first term is 8. I'm dividing by 2, so the ratio is actually 1/2. I could use a decimal if I wanted to. But to find the sum of the first 12 terms, it would be 8 times 1 minus, I'm going to do 0.5 to the 12th power, all over 1 minus 0.5. So 1 minus 0.5 to the 12th. I'm going to multiply that by 8. And then I'm going to divide that by 1 minus 0.5, which is 0.5. And my sum is going to be about 15.996, approximately. This last one, the ratio is a negative number. You got to be careful with this one. And the first term is 5. So we're going to take 5 times 1 minus a negative 2 to the 20th power, all over 1 minus a negative 2. Again, mentally, this bottom, I'm subtracting a negative number, so I could change that to addition. That's 3. On the top, I cannot do that because I'm taking that to the 20th power first. So I'm going to go 1 minus, parenthesis, negative 2 to the 20th power. I'm going to multiply that by 5. And then I'm going to divide that by 3. And my answer, this ends up being a pretty large number, would be 174,7625. So about a negative 1,747,625. That's finding the sum of a geometric series.